Hello, everyone. Thanks for being here. When I first was invited to speak here, I was very excited to talk about all of our achievements in the team, how amazing TELUS is, our award winning collaboration with Google Cloud, and I'm already losing you because it's later in the afternoon. So I decided not to. I've had the privilege of leading a team of natural language processing, NLP data science team, before November 2022, before ChatGPT, and after. And let me tell you, it's been quite a journey. So I decided to instead take you on that journey with me. Let's get started. We're going to start with revisiting some of the more classical NLP techniques, if you wish, some traditional NLP methods. We're going to talk about their use cases, their challenges, everything with examples. And then we're going to talk about LLMs, large language models, and how they directly impacted us as an NLP team. And we're going to, of course, talk about a case study, which I'm pretty sure you'll find relevant because I picked one that is not too niche and is more applicable to various industries. And then I'm going to wrap up with some final thoughts, some takeaways if you want to consider using LLMs in your work. Topic modeling. That's the first technique that I wanted to talk about because that's typically the first technique that you use to explore your data. What it does, and before that, speaking of data, let me introduce or describe the data that my team primarily uses. We work with customer interaction data from call center. So when you call into a call center and you speak to a frontline agent, a representative, we use a Google tool called CCAI, Contact Center AI, that transcribes that conversation into a transcript, into textual data. It also removes and redacts sensitive information out of it. And then that's the customer interaction data that we primarily use. With that, if you do topic modeling on that data, it would look something like that. So as you can see, it's basically a clustering technique, right? And in this case, you want to answer the question such as, what are our customers calling us about, right? You do topic modeling, it identifies common themes. So basically, it puts conversation with similar themes into different buckets, right? In this case, because we are primarily a telco company, it can be internet troubleshooting as one topic or as one cluster, one category. The other one can be billing question, TV troubleshooting, roaming, you get it, right? And it's, again, to get high level information out of your customer interaction data, it's very useful. And it's pretty fast too. And the customer interaction data, it can be emails, it can be surveys, it can be chat. And for instance, if you identify 30% of your conversations or your interactions are around billing, then you can also track that over time and see if it's increasing or you're making some changes in your system to decrease that and if it's actually happening. Let's move on to the second good old sentiment analysis in NLP. It's pretty straightforward. As the name suggests, basically, it helps us understand the emotional tone of an interaction, a text, right? Is it positive, negative? Is it neutral? Are our customers happy, frustrated? They don't care much? And it's based on chosen words and context to some extent. And finally, I wanted to highlight semantic search because you shouldn't have a favorite probably, but I do, and that's semantic search or vector search because it has so many different applications. And what it does is, again, pretty straightforward. You want to identify or find phrases that are similar to your query, to your target sentence in meaning semantically, right? For instance, one example, very, very common one. Your target sentence is, I want to submit a complaint. And you want to very quickly identify and find all of those interactions. Again, it can be emails, it can be surveys, in this case, call center transcripts. that have this sentence or something similar. Because customers, they can phrase that 100 different ways. And this process typically falls into three steps. First is vector representation. And to be honest, basically every NLP technique starts with this step. What it means is that, and it's also called embedding, same thing. You want to convert your target sentence and also your source document into embedding or into vectors so that your machine can work with it. And for the second step, you want to measure how close these vectors, in this case, your target sentence, I want to submit a complaint, is close to other vectors, other sentences in your customer interaction data in this space, in this vector space, right? And then you want to calculate that similarity score. And finally, you rank and retrieve. You find the most similar ones based on that similarity score. In this case, obviously, the most similar one, because those vectors basically are on top of each other, is I want to submit a complaint with the score of 1. The second one can be, how can I file a complaint, right? And the third one is, I need to talk to your manager. As you can see, it doesn't even have the term complaint, but because it's semantically similar to that one, it still gets a pretty high score. Okay, so let's pause here for a second. Can you think of any other use cases for this one? Any other target sentence that you want to right away identify in your customer interaction data? Exactly, about your new services, right? That's a good one. You can, for instance, your target sentence or your query can be, I want to give feedback about your new service, right? Or about competitor if they are inquiring about your competitor. And you might have noticed that there is a sneaky one here. I've been really patient. This is one of those ones, one of those passive aggressive one of those notoriously tricky one for traditional NLP techniques, right? If you do traditional NLP technique on this one and do, for instance, sentiment analysis, it might even get a positive score because it has the term patient in it, right? But we all know that it's not really positive. And that takes me to the limitation of these traditional techniques. When you have sarcasm, you have passive aggressiveness, you have humor. And when you work with real people, real data, customer interaction data, believe me, you find many of those. They are not very great at grasping that nuanced language. The second limitation is that they are not great in interpreting complex queries. Let me give you an example. Back to that topic modeling one, right? True story. You have these millions of interactions. The first question that you want to find an answer for is that what are our customers are mainly calling us about? You do topic modeling, you find, for instance, billing and then troubleshooting. And the next question, almost right away, is that, okay, what about troubleshooting exactly? What's the root cause? And about billing, by the way, are they trying to change their account number? They want to apply a discount and they can't, they are not able to, or they just confused. You know where I'm going, right? It gets very complex when you present this data to the business. And that's honestly the face that we would make, at least internally, because we are professional or with a camera off, working with our business teams as a team of NLP data scientists, that this is, you can't expect miracles from these models. These are just vectors, right? They can't answer this open-ended question for you until they could. Yeah. I know, you might all cringe a little seeing yet another AI generated superhero with LLM and Gen AI on their shirt coming to save the day. I know, I hear you. We've all been there. It's November 2022, ChatGPT appears, and everyone is very excited. It's beyond our wildest dreams. And we think, oh, it's going to change our work forever. In 6 months, everything will be unrecognizable. And let's face it, it didn't really happen like that, right? Yes, as someone with English as their second language, I don't have to wake up in the middle of the night second guessing all of my choices in that email to our VP earlier in the day. Or I can create these images for my presentation. But did it really fundamentally change our work so that it's unrecognizable? Yes, it did. Yes, it did, at least for us. As a team of NLP, natural language processing team, it really did. To the point that we can answer questions that it felt absolutely impossible a year before. And I'm going to share a real example, a success story with you, which the brain behind it is my brilliant data scientist, Rini Gupta here. What was the problem that we were trying to solve? Okay, agents, frontline agents in our call centers, they were required to fill out a lengthy forms after each call. There were like plus 20 drop-down questions, there were summaries, and the process was time-consuming, it was frustrating, and it led to inconsistent and incomplete data. The data was so poor that the business teams, they really couldn't rely on that to make any effective decision. And traditional NLP solutions, they couldn't really handle some of those nuanced questions. And I'm going to share what questions I'm talking about. So the potential for automation was limited. And we had tried. And again, I'm going to share the result shortly. But before that, I want to pause here and talk a little bit about these traditional NLP solutions because we all know, basically in every context, traditional is a very relative term, right? So at the time, like 2021, we wouldn't call the techniques that we were using traditional. We were using BERT, which is basically a pre-trained language model. It has transformer architecture, and it has 350 million parameters, right? So it wasn't just a bag of words model. We were thinking that it's not traditional, right? And it was very powerful, and it is very powerful. But when you compare it to hundreds of billions of parameters of the current large language models, it's traditional. So that's a snapshot of some of the results that we were able to achieve with BERT again. So imagine like BERT, I would say, is like grandparents of some of these GPT-4 models, like BERT, GPT-1. These are our pre-trained language models, but they have, as I mentioned, a few million parameters compared to a billion. And we had 75K training data. And as you can see, for some of these categories or call drivers, it would perform really poorly with F1 score of 0, 20%, 33%. And the priority of those categories were actually high from the business. For instance, if the call driver was an outage, or it was because the customer was moving out of TELUS footprint, or it was install or repair experience, or it was competitor pricing. And I have to say that we had plus 20 other categories that with those traditional methods, we could get a F1 score or accuracy of plus 90%. But still, these ones, since they were high priority, we couldn't automate the whole process. The good news is these call drivers, these exact ones, are now successfully detected using large language models, and the model is in production with plus 93% accuracy. And we were able to add some rare but very important call drivers that we didn't even have with that manual process to our data. For instance, fraud, scam, identity theft, and stolen devices. What was the impact? We were able to save plus 1,000 hours per month. And it's with the assumption that they are only saving 30 seconds per call because it's really a scale, right? And it saves directly hundreds of thousands of dollars for the business per year. Also, the training time was reduced because initially agents they had to be trained on how to fill out that form, so they don't have to do that anymore because it's automated. And more importantly, or at least as importantly, the data quality was enhanced, right? Now data is more complete, more accurate, so business can make more effective decisions. And lastly, improved agent experience. One reason that I really wanted to share this use case among tens of others was that it's a really win 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 use case with AI. It's a win for the company because it saves, as I mentioned, $450,000 a year with this automation. It's a win for business because they can make better decisions with better quality data. And it's also a win for our frontline agents because we were able to eliminate an unpleasant part of their workflows. They really hated filling out that form manually. And I can see a skepticism in some of your faces. Like, did they really hate it? Was that really that unpleasant? And I'm quoting here their direct manager. They hate it with the fiery passion of 10,000 burning suns. I couldn't have put it better. And I wanted to end here, honestly, but I decided to give you three takeaways if you want to use LLM in your work. First of all, is cost implication. These models, using them and putting them in production, can be costly. However, if the last time that you checked the prices was a year ago or 2 years ago, I have good news for you. They are much cheaper now because these cloud companies, cloud services, they just compete with each other and the prices are much better now. But still, if you want to use them at a scale with millions and millions of interaction and your data is very long, like hours and hours of conversation on the phone, it can add up. So what I would suggest is consider using a hybrid model. What do I mean by that? Let's go back to that use case. Remember, I mentioned that for some of those categories, with some of these birth classification models, more traditional models, we could achieve good accuracy. So why not? We decided to keep using those traditional methods for those categories that we didn't have to use LLM. And for some of those other categories, we even use keyword search, the simple SQL, if you want to get fancy regex, to find, for instance, the name of some of the competitors, right? If you want to find the name of a competitor, you don't really need large language models. You can do simply keyword search. And it's very accurate, it's deterministic, and it's very cheap. And then for some of those gaps, some of those categories that none of these methods would work, then obviously you use Gen AI, you use large language models. And with this hybrid approach, you can both achieve accuracy because you're using a hybrid approach, the risk is lower, and also the cost is controlled. And that's why that I started with some of those traditional methods because it's tempting now with LLM models very accessible to answer every NLP question using LLM. It's very tempting, believe me. But I think for every NLP data scientist, it's really important so that they are familiar with the other NLP techniques, right? Because sometimes they are the simpler one are the best solution to do. The other point is having a strategy around evaluation and model to model adoption. What do I mean by that? Honestly, 2 years ago, when we started using LLMs, we didn't think that we have to have a strategy for model to model adoption. We didn't even know that would be a thing in 2 years, maybe in a year. But it is a thing. So when you work with these cloud providers, for instance, we use Google Cloud, and we work with them very closely. These models, they change very fast. So when we started with Palm, then it was Palm 2, then it was Gemini, then it was Gemini Pro, then was Gemini Pro 1.5, right? And I don't expect that to be the last one. And when you use these large language models, typically, oh, and I forgot text Bison. So when you use with these models, sometimes one of those previous models, they became unavailable, right? So how you want to transfer your knowledge, your fine tuning, if you have some, and your prompts from one model to another model. That has been a challenge for our team because as I mentioned, we have to, for instance, migrate from text Bison to Gemini. But the good news is that we found a very cool, useful solution. It's still a working for progress from Google, but I could not share that with you. It's called Google Prompt Optimizer. It's very recent, like it's still in pre-GA, pre-general availability, but you can go and give it a try. It's available on Google Cloud. What it does basically, it tries to solve that problem exactly. So you give it the prompt, you give it your source model, you give it your target model, you can even give it your specified metric, right? And then it will optimize your prompt for you automatically. But the point is not Google Prompt Optimizer. The point is that keep on top of the latest research and papers and technologies because this is cutting edge, right? And there are problems, there are gaps in terms of model to model adoption, in terms of evaluation. But the good news is that new tools, new solutions are coming out every day. And the last one is Gen AI a hype? I get that question all the time, so I decided to answer that before I get asked. What I would say is that antibiotics, probably one of the biggest discoveries of human beings, they can't cure cancer, but that doesn't make them just the hype. Gen AI is the same. It's not a silver bullet. You can't just shove it into every problem and expect great results. But it's incredibly powerful when used in the right context. Thank you.
Hello? Okay, there we go. Does anyone have any questions for Shadi? Questions? Oh, right here up front. Oh, we go. And please state your name and organization.
Hi. My name is Abhishek. I work for a consulting firm called Glenmore. My question, I think you touched upon a little bit about how you're adapting model to model and then using Google Optimizer there. My question is, working with any propensity model, there's already so much challenges, data imbalance, false positive scores. On top of that, there's this constant fear of model degradation over time. How does TELUS specifically handle, or be on top that their models that they've deployed are not degrading, especially serving fairness to the wide demographic customer base that they have, or general using their data, and also in general if they're being integrated into any live systems which kind of create data on the go.
Lots of great questions. So, in terms of making sure that your model or at least your output is still relevant, one way is to have human in the loop, right? That's actually a very powerful strategy to have. And the by nature, the use case that I shared, we have human in the loop, so we get that feedback. That's very helpful. And in terms of the other metrics, even when LLMs came about, really there were lack of metrics. But now, even with Google Cloud Optimizer, as I mentioned, you can have Blue be for bilingual, so it's for translation. In our case, it's classification, so you can Rouge. Like Rouge is typically used for summarization, but you can also use it for classification. And I noticed that there are some other metrics that I wasn't familiar with before, like coherence or verbosity. So again, as I mentioned, it's changing so fast, and lack of evaluation metrics was one of the biggest issue. But I see that we are moving as an industry in the right direction. And what was the oh, in terms of fairness, yeah, very important. So first thing is that the data that we work with, we make sure that we don't introduce any sensitive attribute into our model. As I mentioned, the data, the textual data, it's redacted from all of that sensitive information, such as race, gender, and we don't again introduce that into our data to begin with. And then again, for fairness, there are some other, it's not applicable really in this case, but there are some good metrics out there. For instance, like counterfactual fairness, right? You want to make sure that the output of your model doesn't change if you change some of those sensitive attributes, right? So again, you have to have if your model might be prone to fairness issues, you really have to have a strategy around that, right? And the last question was about like live agent, I guess. Um, yeah, that's $1 million question. So everyone, especially when it comes to call center, everyone wants to know that in like the live agent would replace the whole call center infrastructure. The short answer is no, but the long answer is that in 5 years, everything would look very different. Right now, as I shared in an example, we can really automate some of those very repetitive tasks for agents so that they can focus on higher value activities. But when you call into a call center, the interaction is very complex. It's not just about like chatting with ChatGPT, right? It's not about sharing knowledge. In some cases, it is, and that's why you want to have your bots, right? If it's just about sharing knowledge, because LLMs are great in that. But more often than not, for instance, the customer want to apply a credit into their account. They want to change something in their system, right? So agents, in terms of like agents in the LLM context, they might be able to do that eventually, but we are not there at all. Yeah.
Okay, great. Thank you so much,
Thank you.
Shadi.
Thank you,
Awesome.
everyone.
Great. Thanks so much.
Yeah.